All right, last time on discrete math, we were learning about lists, but now we're going to learn about sets. And there's two very key differences between lists and sets. So what is a set? A set is an unordered, repetition-free collection of objects. Now, unordered and repetition-free are the important parts. Recall when we had a list, right? If we had the list 113, we could write that out. We have the list 113. We could also have the list 131. Now, in both lists, we've repeated an element, and the orders are different. So these two lists are completely different lists, right? The order mattered. Now with sets, we wouldn't be able to repeat the 1, and the order wouldn't matter. So if we have a set like this, let's say we have the set 1, 2, 3, and note for a set I used curly brackets instead of parentheses. So if we have the set 1, 2, 3, which there's no repetition, so we're all good. And then let's say the sets 3, 2, 1. They have the exact same elements, so it's the same set. The order doesn't matter with sets. Hopefully that makes sense. Now, where have we seen sets before? We've talked about sets of numbers, right? Do any of these ring a bell? Z, Q, R, those are the sets. This is the symbol for the set of integers, rational numbers, and real numbers. So we've seen sets before, right? And now I want to talk about elements and cardinality, right? So let's say we had a set. Let's say we had a set like A, right? And A is equal to the set 1, 2, 3. And I want to write the sentence, 1 is an element of A. That's a lot of words, right? And we don't like writing a lot of words if we can shorten it with symbols. So I'm going to use a little symbol that looks like an E, right? And I'm going to say 1 is an element of A. Now, is an element of is a very loose translation. That could also mean is a member of, is in, it's whatever's convenient for you, right? So now, what about this notion of cardinality, right? So cardinality pretty much means the size of a set. And to denote that, we're going to use like absolute value looking symbols, right? So if I wanted to say the cardinality of A, that's going to be equal to 3, right? Because there's 3 elements in A. Now, an interesting thing about cardinality is that it can be finite, as we just saw, or it could be infinite, right? If we have the cardinality of the integers, it's infinite. Now, there's also this really special set called the empty sets. And if you couldn't guess by the name, there are no elements in the empty set because it is empty. Thus, if we wanted to know the cardinality of the empty set, we would say that it is 0. So great, these are some important things that are going to be more important later on when we're applying our knowledge of sets. Now, what is this at the bottom of our screen? Set builder notation, variable conditions. Well, it's called set builder notation because we can write out a very easy way to come up with a set, right? We can build our own kind of infinite set in just a few symbols, and we're going to do that right now. So I have this little formula right here, the variable and conditions, right? So let's say I wanted the set of all numbers greater than or equal to 1, right? I might just say curly bracket, x, and I'll put my colon. Usually when I write a colon, I read such that, so I'll say x such that x is greater than or equal to 1. I'm pretty sure that's what I said, right? And there you go. That's an infinite set of every single number that's greater than or equal to 1, right? But I might want to be a little bit more specific. Am I talking about integers, rational numbers, real numbers? Let's say, hypothetically, I'm talking about real numbers, right? I might add another condition, right? And I'll separate conditions with a comma. So I'll say, okay, I want the set of x such that x is greater than or equal to 1, and x is a real number. So you remember when I said that loose translation about that little E symbol? I didn't say x is an element of the real numbers. I just said x is a real number, right? Now, that's not really standard to write what set your variable is in after the colon. More often, how I've been doing it is we write what element the set is in before the colon. So instead, if I wanted all real numbers greater than or equal to 1, I really wouldn't be doing this. Instead, what I would say is the set of all x in R such that x is greater than or equal to 1. And that's just kind of how standard practice works when you're doing this set builder notation. And I encourage you, if you're thinking of set you can build yourself, maybe the set of all integers divisible by 3, practice that. Try your set builder notation and see if it makes sense. But that is pretty much all we're going to cover for today. I don't want to stuff this video with too much information. Next time, what we're going to do is we're going to talk about subsets, proving that two sets are equal to each other. So if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.